In this video, I want to talk about multiplying polynomials. Here, I have two binomials, 4x plus 2 times 6x minus 4, and I want to talk about how you can multiply these. So first, I'm going to go 4x times 6x. Well, 4 times 6 is 24, so this would be 24x squared. We have to add the exponents. Okay, well then next, let's switch colors. Next, I'll go 4x times negative 4. Well, 4 times 4 is 16, so this must be negative 16x. All right. Then I have 2 times 6x. 2 times 6x. Well, here, I'm going to write this there. So 2 times 6 is 12, so plus 12x. And I'll change colors again. And then 2 times negative 4 is negative 8. Okay. Now, what is going on? Can we combine any terms after we've done this? Yes, I can combine the negative 16 and 12. Okay, so I have 24x squared, and then 12 minus 16, or negative 16 plus 12, is a difference of 4. So I have 4x, and then I take the minus 8. And so this would be the final answer, okay? So we have to distribute that way. Everything gets multiplied with everything, okay? These things in purple here, these are called cross terms, and they will combine here, okay? Let's go on to another example. I have 6x squared minus 6 times the group 4x squared minus 4, okay? So let's see what we can do. 6 times 4, again, is 24. And I have x squared, so this is x to the 4th. Then I have so 6x squared times negative 4 is 24x squared. Negative 6 times 4x squared would be negative 24x squared. And then negative times negative is positive, and that's going to be positive 24. A lot of 24s there. What can I combine? Well, this is x to the 4th, so that has to stand alone. Negative 24, negative 24x squared, so that would be negative 48x squared plus 24. Okay, so that is going to be my final answer for this. Again, we're distributing. Okay, let's try this one. 8n minus 4 times the group n squared plus 9. Okay, so 8n times n squared is 8n cubed. 8n times 9, well, 8 times 9 is 72, so this is probably 72n. Okay, then negative 4 times n squared minus 4n squared, and then negative 4 times 9 is going to be negative 36. Okay. Well, is there anything I can combine? No. If I want, I can rewrite this in descending order, but there's nothing I can combine in this example. Okay. Can you see why I didn't have to combine anything? Can you see what in this problem there was that I didn't have to combine anything? Well, let me know. Okay, so perfect square polynomials. These are very special kind, and we deal with them all the time. So I'm going to actually, call them out by name here. And these are called perfect square trinomials. And here is the formula. They're very simple. They act the same way all the time. But let's look at an example so we can understand what this means. Here, I have the group 4x plus 5 squared. Okay. Well, this by definition means 4x plus 5, 4x plus 5. Okay, it's multiplied by itself. Okay, now I can distribute just as I did before. So 4 times 4 is 16, and that would be x squared because we add the exponents. 4 times 5 is 20. 5 times 4, also 20. And 5 times 5 is 25. Now, can we combine the cross terms? Yes, 20 and 20 makes 40. All right. Now, this is the final answer, okay? But you don't have to, but I want to call out that you can use the formula because these happen. This is always the same. You can use this a plus b quantity squared is a squared plus 2ab plus b squared. Well, what on earth does that mean? Let me switch colors and I'll show you. So in this problem, a is 4x, and then b is 5. So it's trying to say that you can take 4x squared, which would be 16x squared, and then the b squared here at the end would be 5 squared, so that's plus 25. And then you have 2, and we had 2 of the same thing, so that's where that's coming from. 2 times these multiplied. Well, 4 times 5 is 20. If we times that by the 2, we get 40. So 40x, okay? Again, I'm making a note that this is a special kind and that we're going to see these a lot, but you don't have to use the formula to understand these problems. It's just that when we try to understand factoring, it's good to notice what type of problem we're looking at. Let's do another example. Quantity 3y minus 7 squared. Okay, so let's see. This by definition means 3y minus 7. 3y minus 7. Okay, now let's distribute. 3 times 3 is 9, so this is 9y squared. 3 times negative 7 is negative 21y. Negative 7 times 3 would be negative 21y again. Negative 7 times negative 7 is positive 49. I have 2 of the same thing, so I need to put these together. I'll carry the 9y squared down, and so this would be negative 42y plus 49. Okay, this is the final answer. Let's see if we can understand this by that formula that I was on about in the previous slide. So here, what does this mean? Well, it's this term squared, so 3 times 3 is 9. Y times y is y squared. Then negative 7 times negative 7 is 49, positive 49. And then if I multiply these two together, these two terms together, and then by 2, I should get the cross term. So 2 times 3 is 6, and 6 times negative 7 is, I need a negative sign there. That'd be negative 42y. Okay, so you can get it by the formula or you can get it by distribution. Okay, it's probably good to practice both ways. Okay, let's try this example. 2x plus 7 quantity squared. Okay, well, by definition, that's 2x plus 7. 2x plus 7. Okay, so 2 times 2 is 4, so that's 4x squared. 2 times 7 is 14x. 7 times 2 is 14x as well. And 7 times 7 is 49. Okay, I carry the 4x squared down. So we have 28x plus 49. Okay. And hopefully you're not sick of me saying it, but we can also do this by a formula. Okay, so I take this term squared. 2 times 2 is 4. X times x is x squared. I can take this term, square it. 7 times 7 is 49. And then I can go 2 times the first term times the last term. 2 times 2 is 4, and 4 times 7 is positive 28x. Okay, so you can get it by the formula, or you can get it by distribution. Okay, in truth, it's good to practice both ways. The next thing I want to talk about is difference of squares. Now, for difference of squares, they're pretty predictable, so there's even a formula here, but let's see by the distribution of what's going on. The difference of squares is that they're the same thing, except they have the opposite signs. So in the previous video, I called these conjugates. So that's what they are. They're conjugates of each other. Let's distribute them and see what happens. 4x times 4x is 16x squared. 4x times negative 1, negative 4x. 1 times 4x, 1 times negative 1. Okay. Well, look at this. The cross terms are equal and opposite. So when I add these together, I get 0. So I get 16x squared minus 1. Cross terms disappeared, and that's because they're conjugates of each other, all right?